I promise.
Can you promise me I'll get a 90 on the next test?
What? I think everybody can get a 90 on the next test, literally. Yes, everybody. Sit down.
You need an extension plus that?
All right, a sequence is a function whose domain is a set of positive integers. Each corresponding value is called a term. A sequence is finite if it has a limited number, and it's infinite if it doesn't have a limited number. Infinite and finite.
Do you have a pencil, miss?
No.
Anybody got a pencil?
Come on.
It's finite or
Anybody got a
Finite.
Why is the finite spelled the same way as infinite? So would it be infinite?
They are spelled the same. I-N, infinite. No I-N, finite.
Like Arkansas and Kansas. Arkansas, Kansas.
All right. So when I write this, okay. So when I write the sequence, so this is A sub n, and n is the number of terms, okay? So when I have this, if I want the first 5 terms, I want A1, A2, A3, no, A4, and A5. That's your problem.
You tell them this works.
Mm-hmm. I just write this down.
Basically, whatever's in the.
Yep. So look, whatever the n is, this is n, this is 1, so where there's an n, I put the 1. This is 2, so I put a 2. 3, I put a 3. So I just substituted in for the n. I just put that in. So 1 minus 7 gives me negative 6, so this gives me negative 3. This would be negative 5, so it's a negative 2.5.
Yeah, I'm out.
Negative 4. Why is everything my fault?
Yeah, it is.
No. No. Okay, so this is what you get. So, all I did, look, all I did is where this is the n, and I substituted in for n. That's it.
That's all of it?
Yes.
Oh, I love it.
Okay. So, listen. So this is a sequence. So what makes it a series is if I added up the answers, okay? So the sequence, we're just going to follow a pattern. For a series, we're going to add it up. So on this one, come up with the first 5 terms.
Is there always going to be 5 terms, miss?
Well, no, it's going to be whatever it asks for. Here, spread. So spread this out so you have room. All right, so double check your answers and see if you got these.
Oh yeah, I got those.
Correct. So, okay, so even if you had a calculator, the calculator would make this a decimal, right? We're going to have fractions. Also, one of the things I want to point out, if you look at the pattern, what do you see about the signs? So it's negative, positive, negative. So if it starts negative in a series, we're going to use -1 to the n. If it starts negative on the even term, it's going to be -1 to the n plus 1. Okay? Yes. All right. So the next thing I want to do, the next three I'd like to do, is I just want to identify what is the pattern.
1, 3, 5, 7.
I know. So what did I do for each one? I added 2, right? So what are the next three terms? So listen, I got that by subtracting the second term from the first term. So I did 3 minus 1, which was 2. So 5 minus 3, which is 2. So if you did the second minus the first, you always get 2. All right, what about the next one? What did I do here?
Add 3, then add 5, then add 7.
Right. So when I subtracted, I did 3, 5, 7. So the next three terms would be, oh, that's not a 7.
When I do that on the test,
Yours are wrong.
Just be like, I
you
thought it
add
was
9.
the same.
There you go.
There we go. So add 9, 11, and 13. So when you add 9, you get 26, 37, and 50.
I can do this, but we don't need to know it.
Okay, what's the next one?
Oh, that's 2.
They go in order on top and on bottom. So I'm just adding 1. So 6, 5, 7, 6, 8, 7.
5, 6. This is so.
I told you it was easy. Okay.
What's that one test or that one quiz we have in the test?
Okay. I don't know, honey. So a sequence in which you subtract between the two consecutive and it's constant is called an arithmetic sequence. And it's called a common difference. And we're gonna say that that's D. The difference will be D. So if I look at this one, if I subtract 7 minus 4, I get 3. 10 minus 7, I get 3. So the difference is 3. So to get the next two, I would have 19 and 22. So remember, on the next one, you take the second term minus the first term. So this is 45 minus 50 gives me negative 5.
I'm like waiting for it to get a random circle popping up with some
So the homework don't look like that.
Hey, keep up with me. Okay, so when you can't get a common difference by adding or subtracting, the next thing you're going to try is a ratio. And we're going to do that the same way we did the second term, and all we're going to do instead of add or subtract, we're going to divide. So we're going to take the second term divided by the first term. and that's R. We're going to call that R. So when we add or subtract, it's D. When I divide, it's R. So if I take 6 divided by 2, I get 3. 18 divided by 6, I get 3. So R is 3, which means I'm going to multiply by 3. So I'm going to get 162 and 486. Yes. Wrote it down.
That'll be divided by 2.
So this time, I take the second term divided by the first term, right? So it's negative 40 over 80, which gives me negative 1/2. I'm going to check the next one. 20 divided by negative 40 is still negative 1/2. So the R is going to be negative 1/2. This is 5. Or negative 5 over 2 or negative 2.5. Yeah, some we will, some we won't. It won't matter. Okay. It's priority, no. Okay. So, to be arithmetic, you have to be able to subtract or add a common term, right? To be geometric, you have to divide. So if I look at the first example here, what's happening? It's increasing by 2 on top and 2 on bottom. That is not adding or subtracting, and that is not a division, so it's neither. It's a pattern, right? So some of the sequences are just patterns, and the only ones we're trying to look at are the arithmetic and the geometric. So this one is neither because it's a pattern. So this would be 11 over 13 and 13 over 15. So when I subtract 1 minus 1/2, what do I get? 1/2. 3/2 minus 1, what do I get? So my D is 1/2. This is arithmetic. So I would have 2.5, which would be 5 over 2, and this would be 3. So it's just adding a 0, right? So I know it's not subtracting because I don't get the same thing, right? But if I do 0.02 divided by 0.2, what do you get? No, you don't. 0.1. So if these are the same, I'm dividing. So what kind of series do I have? And you're right, though. This just gets bigger by 1. Smaller. More zeros. I'm getting more zeros. Okay, so to get arithmetic, I would have to subtract. I can just tell you right now, if you found it, it would not subtract. If I divide, it wouldn't be a common. But what do I have going on? Right, so I have a pattern. So this is neither.
What makes it arithmetic and what makes it
Geometric is division.